So remember the last thing that we talked about was that there are sometimes when our direct comparison test might fail, okay? And we talked about how a lot of times, most of the time, what that's going to be from is like it's the test or the sequence that we're comparing it to is not the correct either above or below that it needs to be. And so a lot of the time, that is like we're going to have to use a different test at that point. But some of the time when that would happen, we are able to use a slightly different test instead, which would be our limit comparison test. So looking at a sub n, okay, what would we want to compare this series to? Yeah, that's what we want to compare it to, but notice what's a little bit different about this one than the ones that we've previously been looking at. There's another n, right? So like at that point then I wouldn't just be chopping off a constant, right? We would be chopping off a variable as well, yes? So then at that point it's going to be real hard to like justify that it is always going to be smaller than or bigger than the other one. Because we have like a secondary variable that's going on in the middle there. Yes? Are we all okay with that? So we want to compare this to b sub n equals 1 over n squared. But we can't using our direct comparison test. What we can do instead is use our limit comparison test. So it is very similar to our direct comparison test in that we are choosing another series to compare it to. They do both have to have positive terms, but what we do is we're going to take a sub n divided by b sub n, and then we're looking at the limit as n goes to infinity. And if it equals L such that L is in between 0 and infinity, so like we have to get, again, if all of the terms are positive, the limit should also be positive, which is why it caps it at 0. But it also can't be an infinite limit. If we get infinity, then it's inconclusive, and we can't use this test, okay? But if we get some L value, so like some number there, then either both series are convergent or both series are divergent. Yes, no, maybe so. So where this is going to come in handy is with our like little bit messier polynomial type series. A couple people still writing. Another thing to remember, because I kind of had this question before our homework quiz last week, is remember that on your test, like big test, unit test, and also AP test, they will never say like show that this is convergent or divergent by the p-series test or by the integral test, right? It's going to say determine whether it's convergent. It might say show that it's convergent, right? But it's not going to give you a specific test to use. So there are some cases where there's only one test that we can use because of how the function or sequence is set up, right? There are others that you could use different ones. So as long as you use one test or the other correctly, okay, you will still get the point for your work. Does that make sense? Okay, so on that note, this is just kind of what I was telling you a second ago. A lot of times we're looking at things that have messy algebra stuff, okay, where I have more than one in, and so it would be hard to do direct comparison. So we're going to compare it to something that is much simpler and is like a p-series, okay? So I was just writing out what I said a second ago. Okay, because on this first one, okay, we could technically use what? We could use a direct, right, or at least attempt it. We can make sure that it's above or below as we need it to be, okay? But this time we are going to just do our limit comparison test instead, just to practice with that, okay? Because then we're going to work our way to something to part B that's not quite as nice. Yes? Okay. So on our first one, so this is my A sub n, what do we want our B sub n to be? 1 over n cubed. Yes? Now we do want to note, is 1 over n cubed convergent or divergent? The series of that. By what?
Because B is greater than.
Yeah, because car is greater than.
Oh wait, it's.
Oh wait.
This is a P series, not a geometric.
Oh.
It's convergence.
So it does converge. Are we okay with that?
Yes.
Because P is
Greater than.
bigger than 1. Okay. But also notice that we are adding to the bottom, yeah? So B sub n would be what compared to A sub n? B sub n would be what compared to A sub n? Right? Greater?
Wait.
Smaller.
I don't
Yes.
know.
Denominator's bigger.
So B sub n is convergent.
Mm-hmm.
Yes. Our denominator on this one is bigger, so A sub n would be smaller than B sub n. So could we have used our direct comparison if we wanted to?
Yes.
Yes. Okay. That's all I was getting at. Is that we technically could have used our other one.
What I don't understand, like the 2 on our original function makes you think that it's bigger.
I mean, that one is bigger.
But like, I don't know. It makes me think that A of n is gonna be greater than B of n.
Okay, and if we needed to convince ourselves of it, remember that we could like write out a couple of things. But that is one of the reasons why this one might be better for us to do the limit comparison test, because not only are we adding something to the bottom, but we also are multiplying something on top, right? So there's 2 different things going on there, instead of just one or the other. But if it's a constant, for the most part, that's not going to override. It just depends. So if you wanted to write it out to use the comparison test, you would want to write out your terms, kind of like we did on a couple of other ones. Does that make sense? But again, if on some of them, if you would have to like write out your terms, like convince yourself, sometimes it's just more, it's more quick to do the limit test instead, as long as they're both positive. Does that make sense? So it just kind of gives us another option if we can't confidently say one series is bigger than the other series. Alright, but we did say that B sub n is going to be convergent. Yes, no, maybe? Are we all okay with that part at least? Yes, by our P series test. Okay. So, then, what did we say we wanted to look at? It's the limit comparison test, so we're going to look at a limit. Okay, it's a good place to start. And it is a series, so we're looking at the series, the infinite series. So it says n goes through infinity. And then it was A sub n, yes, which is our original. Divided by B sub n? Yes, no, maybe? Are we okay with that? And now we're trying to evaluate that limit. So what would I want to do first? And these are all infinite limits, agreed? So remember, with our infinite limits, you have one of two ways that you can think about it. One, we can think about at the end of the day, is that plus 4 going to do all that much to my bottom? So really, we only have an n cubed divided by an n cubed, but if I have n cubed divided by n cubed, what is that? Just 1, and so we would just be left with 2, right? The other way that we can think about it is if you want to go through all the actual algebraic steps is, remember, I can divide the top and the bottom by the largest degree, right? So I would do divided by n cubed, divided by n cubed, and I would do 4 divided by n cubed. Well, my 4 divided by n cubed is going to go to 0, because my denominator is getting infinitely big, and then my leading terms for both of those, the n cubes, will reduce out, and so you would just have 2 divided by 1. Yes, no, maybe. Do you recall what I'm talking about with our infinite limits, where we had to divide and make all the fractions and stuff like that, which is just a lot of work, so I wouldn't suggest writing all of that out, but hopefully we can kind of think through it if we needed to. So what is our limit going to equal here? 2. So did I get a number?
Yes.
Yeah. So we can say, therefore, the summation of our original converges since the summation of 1 over n cubed converges by the limit comparison test. So here's a nice question. Does that mean that my a sub n, or sorry, the series of a sub n, does that mean that that converges to 2? No. Some of us missed that one on a multiple choice question. Because remember, if I'm using any of my other tests, either my limit being a number or the integral test with the integral being a number, that does not necessarily mean that that's what that series converges to. That just means that that series is convergent. Bear with me. The only one that we have specifically looked at, like a formula to give us what the series converges to, is our geometry. What questions do we have? Okay. Okay. Now, does our second one look like fun? Would we want to try direct comparison on that one? No. We might have been able to finagle our way on the first one with writing out a couple terms and trying to get it to be proper, right? But the second one, we definitely don't want to do that. So this is one where you would definitely want to do a limit comparison test, okay? Now, what do we want to compare it to? So I'll break it down. For the most part, we get rid of all of the constants or stuff that's not my leading terms. Are we all okay with that? So for my b sub n on this one, okay, I want to break it down just to my n to the 4th divided by n to the 5th. Okay, so I'm just looking at those leading terms. Are we okay with that? But what does that technically equal? 1 over n. And 1 over n is what? Which is? Divergent. Which means that if I get a answer for my limit, this series will also diverge. Because they both do the same thing. If we get a final answer. Again, remember, if I get an infinite limit there, it's inconclusive. Yeah.
So how do we know for sure that the n cube is not going to affect that?
Rephrase your question for me. What do you mean by affect it?
Like,
Because remember, I'm not using the direct comparison test. If I was using a direct comparison test, I would need to be able to to convince myself that my b sub n was either bigger or smaller as necessary, and that that n cubed wasn't really affecting it. Are you with me there?
yeah.
Okay. But with my limit comparison test, basically what we're doing is we're trying to set ourselves up, okay, to where I get something that looks like this. Yes? So basically what we're doing is we're manufacturing to see, do the rest of those things really matter or not, okay? By taking the limit of one thing divided by another, okay, I'm saying if I divide out the biggest terms of that, basically, okay, do I end up with something that still goes to infinity, right? Because if I end up with something that still goes to infinity, that means that that n cubed did affect it enough that I can't use my limit comparison, right? If I get something that's just a number by dividing out those first terms, right, that means that the rest of that stuff does not affect it enough, okay, in order to change the behavior of the entire thing. Does that make sense? So basically by taking the limit, we are trying to convince ourselves, does that stuff other than my first two leading terms affect it enough, right? Which with polynomial type stuff, it's not going to, right? Because if it's in descending order, the n to the fourth is going to have a greater effect than the n cubed. However, if I had something like minus e to the n, right? Now it is still going to affect it enough that you are going to get some sort of infinity type thing there, and you wouldn't be able to use your limit comparison.
So like, if we wouldn't like try to find something else to compare it to that would have like an into the cube term. It just won't work regardless.
Again, if it's a polynomial, it's gonna work. But like if you had an e to the n or something else that was going on there, I would not spend the time required to try and figure out something to compare it to that's gonna work. Does that make sense? Like I would use one of your other ones. We're gonna look at the ratio test next, and that one works best with exponents. Does that make sense? Like, could you again finagle your way to find something that could potentially work? Maybe. It's gonna take a long time, and like on the AP test, you don't have the time to do that. Does that make sense? Okay. Sure, that's a lot of words. Alright, so then, if this is what I'm comparing it to, then what are we looking for? Yeah, the limit at, okay, okay. Are we all okay if I just multiply by the reciprocal at the beginning? So I don't have to draw giant fraction? Yes? Okay. So again, we now have an infinite limit, so we can either think about dividing everything out if we wanted to do it algebraically, but hopefully we notice that now that my exponents are the same, it's just going to equal my leading coefficients. Agreed? Yeah, so what do we get? 1/4. Is 1/4 a number?
Yes.
Yeah, okay. So will it converge or diverge then? Diverge, because my b sub n diverged. So, the sum as from n to infinity of my original function, which usually, for some of these, writing out your conclusion statement is longer than some of your work is divergent since the sum of 1/n diverges the limit comparison test. Yes, no, maybe. So now I will tell you a secret, okay? But don't abuse it. As long as you have met all of the requirements of whatever test that you're using, okay? So notice that I stated that my b sub n was divergent. I found my limit, and I got an answer there, right? That's all of the requirements of the limit comparison test, okay? You will not be taken off points for not stating by the limit comparison test. Now, for the AP test, For my test, I do want you stating which one you're using, because if you don't know which one you're using, there's a fair chance that you're not using the right requirements, right? Which is why we're practicing labeling which tests we're using to make sure that you're meeting the right requirements for each of them. But if you just remember that, oh, it's the limit one, but you don't remember the exact name, you don't necessarily have to list the exact name. But right now, I do want you listing out those actual tests that you're using, just so we get better at knowing which one to use when and what the requirements are for each of our tests. Yeah?
So I know in our previous explanations we had to explain how we knew that the B sub n was divergent or convergent. Do we have to list that for like CAP tests?
You mean for the B sub n?
Yes.
Not necessarily, because usually, again, with our limit comparison test, we're comparing it to a P-series test.
Okay.
And P-series are going to be, like, pretty, right? Like,
So-
you're going to see it. However, if you wanted to, over here on your side, just so that your, like, conclusion statement isn't, like, 4 sentences long, you could say this is, as P equals 1 is convergent as P equals 3, right?
Okay.
So then you're still stating why you know this. Just that way then maybe you're convincing yourself and reminding yourself why this is convergent or divergent. And then this then carries over to your conclusion statement, so you don't have to state it again. Does that make sense?
Yeah.
It's not a bad idea to list it. I was just running out of room on both of mine because those statements can get a little long. Yeah.
Is that only for the limit comparison test? Like, what about the other ones, like PC and the geometric C?
Like, if I was just given, like, my original series was 1 over n cubed, then yeah, I need to state this is convergent as P equals 3, 3 is greater than 1, right? You don't necessarily have to say, on the AP test, you don't have to say by the P series test, but you do have to list out the requirements of P is greater than 1, so basically you're doing that anyway, but I want you to list out the test that you're using, again, just for us to, like, build practice on the different tests that we have.
What happens if P is a negative number and we can't use the B series test?
So if P is a negative number, then technically it would just be in the numerator. So like if I had 1 over n to the negative third, it's technically just n cubed, and now it's no longer a P series, right? Because my Q series is specifically a fraction of 1 over n to the P, right? Now you could start with something that has negative, right? N to the negative third is a P series because I can rewrite it as a P series, but it doesn't go the other way because then now technically it's not a P series because it's not a fraction. So you would have to do something